welcome you to my channel Knowledge Center. Today we are going to discuss about the time, distance and the speed, but a new concept in that is late and early concept. So it sounds something different, but you get so many questions on this and this will be a bit complicated. So I am going to give you the shortcut method of solving the late and early concept of time, distance and speed. So before going into that, just want to give one formula which will be used for shortcut solution. Okay, so that is, there is a formula for a distance in which we will have delta t into speed 1 into speed 2 whole divided by speed 1 minus speed 2. So this formula can be used only for these kind of questions which I am going to give in this video. That is, here two cases has to be available. Speed 1 for case 1, speed 2 is for case 2. I will just give an example. Means there may be questions like a person is moving from his house to an office at a speed of certain speed. Say speed is S1, at certain speed S1, and he reaches his destination by 5 minutes late. That is first statement. He starts and he reaches the destination by 5 minutes late and his speed is S1. Now the same person increases his speed and reaches the destination 10 minutes early. So these are the two conditions. Okay. So second speed is S2 and he reaches 10 minutes early. So what is the actual distance? So this is how the questions will be framed. Right. So when we have two statements where we have a concept of late or early, then we use this formula to find the distance. So that's why it is called as I told you that the concept of this today's class is late, early. Right. So I give you the shortcut method and also I will tell you how to solve using the traditional method. So first let us take one example to understand this concept of late and early. So you can look into the screen, you get the question over there. The question says that a man goes to his office. A man is going to his office by a scooter at a speed of 30 km per hour. Say this speed, let me take it as 1. At a speed of 30 km per hour and reaches 6 minutes earlier. So if he travels at this speed, he reaches the destination, his office, 6 minutes earlier. Okay. But we don't know what is the exact time, exactly at what time he reaches, but 6 minutes early he reaches. Okay. If he goes at a speed of 24 km per hour, he reaches 5 minutes late. That's the concept. Second speed is, if he goes at 24 km per hour, if this is the speed is reduced, he reaches 5 minutes late. Okay. So let me note it down, 5 minutes late. So early, in this case he is reaching early. In this second case he is reaching late. Okay. Now the destination of his office is how much? That's the question. They have also given some options. Here the options are 20 km, 21 km, 22 km, 23 km. So 4 options are given. You just need to find out the correct one. Okay. 20, 21, 22, 23. Now let's see how to solve these kind of problem traditionally, and then after I will tell you what is the simple way or a shortcut method. Okay. Right. So let's first thing what you need to understand here is the time chart. The time chart is nothing but the actual time taken to reach, or the difference. We have some information here. Let us write it in a chart in a simple manner so that we can understand the concept. Say in time chart I can say that here nowhere they have mentioned that at what time they are going to reach. They have mentioned that they reach early or late by some minutes. So let us assume that time. Generally a person going to office means what will be the time? In the morning 10 o'clock he will be moving to office. So I will assume that 10 o'clock is the standard time. Okay. So that is what we use the time chart. Say 10 a.m. He should be at the office exactly at 10 a.m. So in case 1, it says that he is moving at a speed of 30 km per hour. In case 1, he is moving at 30 km per hour. If he goes at 30 km per hour, he reaches the office 6 minutes early. So what is its time? He should reach at 10, but he reached 6 minutes early. So I can say that he reaches at 9:54. 9 am 54 minutes. 9 hours 54 minutes. At that time, he will reach the office. According to this statement, I am writing it here. In the second statement, say his speed is 24 km per hour. This is the speed. So if he moves at 24 km per hour, he reaches 5 minutes late. So you need to reach at 10, but you will be late by 5 minutes. So what will be the time now? 10:05. He will be in office at 10:05. Right? So this what we call it as a time chart, and this is the point we assumed. Okay? So that I can identify the times here. Right now, what is the difference? See the difference between these times. Here it is 9:54 and 9:54 in the sense actual time is 10. That's what we assume, and he is reaching at 9:54. So he is reaching 6 minutes early. That's what the information. And here he is reaching 5 minutes late. So 5 minutes late. Right? We need to add these two time now. Add these two time. 6 minutes and 5 minutes. So that will give you the 11 minutes. 11 minutes. Okay? That is going to give you the 11 minutes. And this is the difference of time from first case to second case. Okay? If he is at this much of speed, this is 6 minutes. If he is at this much of speed, he is late by 5 minutes. The total difference is 11 minutes. Difference between this time and this time, it is 11 minutes. So that is what I can say. Here we can write it as T1 minus T2. We got 11 minutes. Using this, we can solve the problem and identify the distance. So what is that? We know that the relation between speed, distance and time. Okay? We know that T is equal to distance traveled by speed. Okay? We know this relation. So now T1 means I can write that D by S1 minus T2, I can take it as D by S2. See, here we need to concentrate one important thing. I have not mentioned D1 and D2 because I know that the distance between the home and office is same. Only the speeds have been changed so that the time has been changed. So I will take the distance as D. Whereas speed is different, so I am taking S1 and S2. So T1 can be written as D by S1, T2 can be written as D by S2. That difference is 11 minutes. Here we have information of speed 1 and speed 2. S1 is 30 km per hour. So let's substitute that. So it can be written as D by 30 minus D by 24. Whereas this 30 and 24 are in kilometer per hour. And here time is in minutes. So let's convert this time in hours. So how can we write it? 11 by 60. That will be in terms of hours. Because we have the speed in kilometer per hour. So let me have the time in terms of hours. Okay, 11 minutes means for 1 hour it is 60 minutes. So 11 minutes, how many hours it will be? So 11 by 60 will be the hour. Right. So now take LCM of this. I will write it. I will erase this and I will continue it here. Right. Let me continue it here. So what is an LCM 30 and 24? We can say, let me take 120 as common LCM here. 120. 34 is a 120. So into 4 here. So we get 4D minus 24 5 is a 120. 5 4 is a 20. 5 to the 10 120. So into 5 here. So it will be 5D is equal to 11 by 60. Now once we simplify 4D minus 5D, we get it as a D, 1D. Actually you may say that it is minus D, sir, but it's a distance, so there is no point of having a minus over there. So just we take it as a D is equal to 120. I will take it to this side into 11 by 60. Right. So 1s are 2s are, totally it will be 22 kilometer. That is the distance. So among these options, here option C we have it as a 22. So this will be the right answer. So it took some time for you to calculate it, right? So we found first we calculated the difference of this and then we substituted according to this and we got the answer. Now let me tell you the simple method, that formula which I have explained. Now let us take up that formula and see how to get the answer within fraction of seconds. Okay, so let me erase this portion. I will erase it. Now here itself I will tell you the second method, that is shortcut method. We have a formula that is D is equal to del T S1 S2 by S1 minus S2. Just substitute the values. What was the del T? Del T is nothing but the difference of time, right? And that we got it as 11 minutes here. And here how to calculate that I will tell you. In this question, we have concept of early and late. So in one statement it is early and in another statement we are reaching late. If you have late and early, or if you have early and late, then you need to add the time. You need to add this time. Okay. Or if you have, in a concept, if you have late and late, or if you have early and early, in both the statement you are getting late and in both the statement if you are getting early, same you are getting, then that time should be subtracted. We need to remove it. We need to subtract it. This is the logic. This is the short trick you need to remember. Okay. So then no need of writing the time chart and all those things. By just looking into this condition, you can add it or you can subtract it. Now according to this question, we are in this condition. In one statement it is early, in another statement we are getting late. So early late. If early and late, then the time has to be added. Okay. So remember this. This is most important. In next questions we will use this and we will solve the problem. Okay. So now according to this statement, it's early and late. So the time what we have delta t, that we can obtain by adding these two, 6 minutes and 5 minutes. So delta t will become 11 minutes. So it is in terms of minutes, but speeds are in terms of hours. So we just write it as 11 by 60. That is in terms of hours. Okay. Then S1. So what is the S1? Is 30 km per hour into S2 24 km per hour by S1 minus S2. So 30 minus 24 km per hour, that is 6. We get the difference here. Now if you simplify this, we can do it like this. 6 ones are 6 5s are. Okay. 5 ones are 5 12s are 60. 12 ones are 12 2s are 24. So remaining 11 and 2. So the distance will be 22 kilometer. That is what we got here. So within just a fraction of seconds, I have just taken a time because this is the first problem. You can just write this formula and identify whether we have late and early or early and late or late late or early early. Right? Based on that condition, this two has to be added or it has to be subtracted. Right? And then include that here and substitute it. We get the answer. It's very simple. I hope it's clear for you. If it is clear, like the video and don't forget to comment on this. Okay. Now I'll go for a second question which we will solve it using the shortcut method so that it will be easy and faster. Okay. So let's look into the screen now for the second question. So in second question, we have the question something like this. Walking, you can read the question now. You can pause the video and look into a question. I will just write the statements here. According to that question, walking at 5 km per hour, a man reaches his office from his house 15 minutes early. So one speed 1 is given as 5 km per hour. 5 km per hour. If he is walking at 5 km per hour, he reaches his office 15 minutes early. So 15 minutes early. Right. So second condition is if and walking at 3 km per hour, he is late by 9 minutes. So if he walks at this speed 3 km per hour, he will be late by 9 minutes. Late. So it is early and late. Okay. So what is the distance between his office and house? That's the question. So simple trick. First check for this, whether it is early late or same early. We have different early and late. So we need to add the time. So 15 plus 9, that is 24 minutes. And we have this in terms of kilometer per hour. So let me write it in terms of hours. 24 by 60 hours. This is what we got. This is delta t. So that's the difference of time. So now apply that formula. D is equal to delta t into S1 into S2 by S1 minus S2. So delta t is 24 by 60 into S1 is 5, S2 is 3 by S1 minus S2, that is 5 minus 3, that is 2. 2 1s are 2 12s are 24, 12 1s are 12 5s are 60, 5 1s are 5 1s are cancel, we get 3. So the distance is just 3 kilometers. The distance between the office and his house is 3 kilometers. So this is how the problems has to be solved. Okay, this is so easy. You can try it using a traditional method also, but it takes time. This is the shortcut method to get the answers. Now you try it on a third question. Let me give the question. A girl walking at a speed of 20 km per hour. So walking at a speed of 20 km per hour reaches her school 30 minutes late. So if she walks at this speed, she reaches the school 30 minutes late. Here it is early, so let me erase it. She reaches the school 30 minutes late. Okay. Next time she increases the speed by 4 km per hour. See, the second speed is not directly given. It is given as a statement. Next time she increases the speed by 4 km per hour. So next day what she will do? She increased the speed by 4 km per hour. So in first day she was walking at 20 km per hour. So next day she increases the speed by 4 km per hour means 20 plus 4, that is 24 km per hour. So this is how the question, a small twist in the question. Increased the speed by 4 km. So earlier it was 20, now it will be 24 km per hour. But still she is late by 10 minutes. See, this is one more important thing here. Even after increasing the speed by 4 km per hour, she will be late by 10 minutes. She will be late by 10 minutes. So find the distance between the school and her house. Right. So here both the cases we have late, late. So if it is late and late, we should subtract. That's the concept I told you. So that is the short trick. Yes, we have late by late. So we will subtract now. So the delta t is going to be obtained by subtracting the time given. Therefore, delta t is equal to 30 minus 10. That is 20 minutes. So let me write it in terms of hours. 20 by 60 hours. That's it. Now, in D is equal to delta t, that is 20 by 60 into S1 is 20, S2 is 24 divided by this minus this. It may be 20 minus 24 or 24 minus 20. You take the larger number first and the smaller number the next, so that we not get confused with the negative signs. So 4 kilometers. 24 minus 20, it's a 4. So 4 1s are 4 5s are 20. 5 1s are 5 12s are 12 1s are 12 2s are 24. So totally left out 20 into 2, that is 40 kilometers. So the distance between the school and house is 40 kilometers. So all these three questions are something similar, but we have understood I hope you have understood the concept of late and early, early and late. What happens if both are late, if both are early, right? So finding delta t is going to be important, right? So if both are same, late or early, you should subtract the time. If both are different, late, in one case it is late, in another case it is early, then you should add the time. Now let's move on for the last question, that is the fourth question. Let's see how it is different. If a car runs at 40 km per hour, so that is the concept. If a car runs at 40 km per hour, it reaches its destination late by 11 minutes. So if the speed is 40 km per hour, a car is driving at that speed, and if it reaches the destination late by 11 minutes. So 11 minutes and it is late. Now, but if it runs at 50 km per hour, second speed is 50. If it runs at 50 km per hour, it is late by 5 minutes only. So in both the cases it is late, but here the time duration is different. 5 minutes late. If the speed increased to 50 km per hour, then that is going to reach the destination by 5 minutes late. The correct time in minutes for the car to complete the journey is dash. So here they are not asked you to find the destination, distance. They asked you to find what is the correct time. What is the correct time in minutes? So you should find the time in minutes. What is the correct time in minutes by which the car reaches the destination? So what would be the correct time to complete the journey? That's the question. Here no need of, they are not asked you to find the distance, but we have a formula for distance only, right? So first we will find the distance, and after finding the distance we will try to find what is the correct time to reach the destination. This is not the correct time. They are late by 11 minutes. Here also they are late by 5 minutes. So we don't know what is the exact time by what it is going to reach the destination. They have given the options here. Options are 13, 15, 19 and 20. So these are the 4 options. So again you do the same thing. First find the delta t. First understand these two are late. In both the condition it is late. So if it is late, you should take a difference of it. If it is late, you should take a difference of the time. So 11 minus 5 is 6 minutes. So 6 by 60 is the hour. In terms of hours in it, right? So keep it in hours. Then D is equal to delta t into speed 1 into speed 2 by the difference of that is 10. 50 minus 40 is 10. Okay, right. So now what you can do, you can just simplify it. 10 ones are 10 5s are 5 ones are 5 12s are, isn't it? 6 ones are 6 2s are 2 ones are 2 20s are. So the distance is 20 kilometers. Now you may be feeling that what is the need of finding a distance when they have just asked you to find the actual time. See, if you want to find the actual time to reach the destination, we need to know what is the distance, traveled, right? So that's why I have find the distance. Now the distance traveled is 20 kilometers. Now you use any one of this statement and I can find the answer for this. So let us use the first statement. You can use first or second, any one of the statement. I'll make use of a first statement. So first statement says that speed of the car is 40 km per hour. So for 1 hour, it is traveling 40 km. But the actual distance what it has to reach is 20 km. So to reach this 20 km, how much of time we require? According to this, for 1 hour, it is reaching 40 kilometers, right? So to travel only 20 kilometers, I need half of it. So half an hour, or we can say 30 minutes. One are the same. Because I want to answer in minutes, so I'll try to keep it in minutes. So I want just 30 minutes to reach the 20 kilometer, right? So to reach this distance, the time taken is 30 minutes. But don't forget this. Here it is mentioned in the statement that, okay, it reaches in 30 minutes, but it is late by 11 minutes. So what is the actual time now? It is late by 11 minutes means 30 minus 11 minutes. That will be the 19 minutes. So 19 minutes is the actual time to reach the destination, right? So option here is this one, 19. So this is how you need to solve the problems. It may be asked to find the distance, or it may be asked to find the actual time, but late and early concept, this concept is most important. So I hope this is very clear for you. If it is clear, like the video and don't forget to subscribe to my channel. Thank you.